Now we're going to move on to graphing the sine and the cosine trig functions. And just a quick review of what you did previously with graphing. You were given a function, and then in order to graph that function, you chose x values, plugged them into the function, and then got a y output. And then you had this xy ordered pair that was created from your xy chart. And if you wanted to, I could choose any value for x to plug in and solve. I could make this be 3,000 if I want. But we want to choose numbers that are beneficial to us in order to solve. And when we had rational functions, we chose points around our asymptotes. Here I can see if I put a -2 in the denominator, I would then have a vertical asymptote. And so I chose numbers close to that were easy to work with, that I could graph on the coordinate plane. I very easily right here could have chosen a -2.00625, but that's not a clean number to work with. We chose whole numbers. We're going to use that same approach graphing trig functions, where we are going to plug values into our equation and get an output, and then plot that output as an ordered pair. However, we're going to have to be very strategic in the numbers we use with sines, cosines, tangents, and so forth. We don't want to choose any random number. We want to choose some smart measurements to use, and those measurements are going to be from the unit circle. So the first one we want to graph is y equals sine of x. We're going to use the same approach as we did before, where we're going to create an xy chart. But instead of me saying sine of 1 or sine of 2, those numbers are so bizarre, you would not know those off the top of your head. We're going to use values from the unit circle. And the easiest values from the unit circle to deal with are going to be the zeros and the pi's over 2. So let's say I go 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. And then going in the other direction, negative pi over 2, and then negative pi. So the x here indicates my angle measurement. And the y value is going to indicate the output of the function. So if I go to my unit circle, the sine of 0 pi, or sine of 0, is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. If I do the same thing going in the other direction, sine of negative pi over 2 is -1, and then sine of negative pi is 0. So I've got this 0, -1, 0, 1, 0, -1, 0 pattern going on. And I want to begin to plot that. Since my input here, or my x value, indicates angle measurements, I'm going to make my x-axis here be angle measurements. So I'm going to set a scale. Let each tick mark, or each line on the graph, represent pi over 2 in the x direction. So these marks that I put in each represent pi over 2. So this is pi over 2, this would be pi, 3 pi over 2, 2 pi, and so forth. And then going in the opposite direction, we're going to be moving negative. So each of those represent pi over 2. For the y direction, let each tick mark represent 1 unit. So we're going to have the same scale we normally have. So this will be 1, this will be 2, -1, -2. And now I'm going to plot out those points that I see from my chart. Here I see 0 pi and 0, which means I'm going to be right there. Here, pi over 2 and 1 unit up. So this is pi over 2, 1 unit up. pi and 0, 3 pi negative 1, or 3 pi over 2 negative 1, and then 2 pi 0. And this pattern continues of negative 1, 0, positive 1, 0, negative 1. And it goes in both directions. And the graph of the sine curve is this wave that we get. And it continues forever in both directions. If I'm not sure what that graph is going to look like, I can plot even more points from the unit circle. Here I could put in a pi over 6, or a pi over 4, or a pi over 3, and see that that value is less than 1. So it's going to gradually get closer and closer to 1, which gives us that curve feature. If I wanted to confirm that on the graphing calculator, I could by typing in y equals sine of x into my graphing calculator, and then clicking on the zoom button, I would choose option number 7, which is zoom trig, which then sets my window up for trigonometric functions, and I can see the general sine curve that I get. I can do the same approach with the cosine function, letting x representing my input, y being my output. And I'm going to choose the same strategic points that I did before. So once again, x is my angle measurement, and then y is the output. So I'll go through and solve that, but this time using the cosine. The cosine of negative pi is negative 1. The cosine of negative pi over 2 is 0. Cosine of 0 pi is 1. And I'll fill in the rest of my table. Exact same approach as I did with the sine curve. I'm going to let each tick mark represent pi over 2 units. And when I graph the cosine curve, I'm going to see that I start at 0, 1, and then I come down. So there's my cosine curve graph. It looks just like the sine, except for my starting point is 0, 1, and I come down, whereas here for my sine graph, my starting point was 0, 0, and I went up. But it's the same basic shape. And as we mentioned before, these are cyclic functions, which means they keep on repeating, which is why you see this rise and fall of the sine and cosine curves in the same pattern. From the unit circle, which value is sine? We said that's the y value. What is the domain of the sine values? When you look at this, are there any asymptotes? Are there any holes? Anything that causes the graph to break up? And the answer is no. So we go from negative infinity to infinity. And when we're talking about that, we're plugging in angle measurements from negative infinity to infinity. And then finally, what is the range for the sine value? When you see here, it goes up to negative 1 and down to negative 1, including 1 and negative 1. That ends up being my range.